Thanks everyone. Thanks for the introduction. I don't have to say the first part of my presentation now, which is great. And it's nice to be here amongst fellow manufacturers and you know, our industry being alive and well. It's definitely a tough industry. As was in the introduction, I started the business with my father back in 2006. He passed away in 2014, so it's about the same sort of time with my father as without, and it's been quite a journey. He would be very proud to see this today, which would be fantastic. So the green button takes it forward. These are all products that we produce. We're an SME. We've got about 60 people, and all of these products are produced based on our composite materials technology, which is a platform technology that we developed at the outset. Really, we set up in Maxville with 3 people, and my capital and friends, fools, and families, as they say, to develop a system of composite materials that now underpins all of these products. We are the major manufacturer for transport equipment for aggressive corrosive chemicals, servicing mining industry, water treatment industry, and this kind of road train is built to take heavy acids to remote mines. Australia is an incredible proving ground for technology and equipment. This operates in extremely harsh conditions, and we spent a long time developing technology and products which has enabled us to get into the offshore markets. Our CTO, Luke Jukic, is here today. Around about the time Luke joined was when we set about the task of developing our technology to suit international markets, and this is the world's first carbon fibre composite ISO tank container. It uses our technology for the interior of the tank, and we now produce these here in Australia and export them to the United States and Europe. This is an extension of that product developed to suit the European market. It's called a swap tank. This is now in use in Northern Europe in the chemical corridor there, transporting aggressive corrosive chemicals for one of Europe's major chemical transport companies. It was reviewed recently by the technical purchaser of that, and the review of that with our salesperson on the ground gave the feedback that this is really the technology that they wish to use. The challenge is getting it into the market. So we're there, we're in the market. Those deep pools of capital to allow scaling is the key. This is a project with AMGC, the development of our technology into a United States road tanker, and the AMGC team helped us to launch this into the United States. The press, we had Arthur Sinodinos, the Australian ambassador to the United States, attending the launch, and this is now commercialising in the market. We've sold the first 20 units, and with a very strong pipeline for growth in that market. So it's all leveraging technology which we're now extending into the emerging hydrogen market for high pressure gaseous hydrogen, but also liquefied hydrogen, one of the extremely challenging cargoes. And for lightweight composite tanks to overcome these challenges, we're using technology that we've developed and also technology developed by the UNSW in a project with Lockheed Martin. So I'll talk a little bit more to that later. So where do we sit today? We have advanced composite materials technology. We've patented that in 51 countries. We have a strong share of our domestic market, which we're leveraging now to launch into international markets. It's a large addressable market for these liquids that we transport. We have a strong value proposition for these complex liquids and gases, so we know our niche, and we have good engagement with major multinationals in gas and aerospace. I reflected personally on our pathway to developing technology and how does that happen, how it happened for us, and you know, what are the things that have to come together to make it happen. There has to be an industry problem and that need for a better solution. It's a kind of intersection there where you have to have technical knowledge in the space, and the deeper your technical knowledge, the better you're versed on what currently exists. It has to have that little magic dust, the inventive step for the technology development, and then it takes a whole ton of hard work resources, determination, and an incredible team around you, which Omni Tanker has. It kind of all fits together there, and in the middle sits this little bit of new technology which develops to change an industry, and that's where we're up to. So what was our industry problem? Some of you may have been around when these planes first came into Australia, the F-111s. A lot of them came into Australia in groups of 4, and then they sat on the ground for a few years because their fuel tanks leaked. They're a long-range plane. They have much of the plane is dedicated to fuel storage as well, and they had linings inside those which broke down and leaked fuel. So the concept, and then these people on the wing, aircraft technician, had to climb into there, de-seal and reseal them, and that was a terrible kind of chapter in the RAAF's history there, where these technicians got terrible ill health. So the technical challenge there is to create an extreme resistant vessel with lightweight and structural strength that really creates then that durable containment of a challenging liquid, in this case Jet A1. That was the headline there. Most of these technicians that had to do that job passed away from cancers. And this is the technology that we've developed to solve that challenge of a durable vessel for a complex liquid which can be lightweight and structural. And this is the inventive step: to connect to thermoplastic materials which form extraordinary barriers but have very low structural strength, and to connect them with carbon fibre composites so that we can generate a vessel with a thermoplastic interior and a carbon fibre composite structure. It's in effect sticking to Teflon, but generating vessels, an inner and an outer vessel with a structural connection, high integrity union. And so if I put that into, we've had marketing people develop terms for this, the armoured thermoplastic tank, but it's all about that exceptional chemical resistance and the strength to weight. So the internal tank is a seamless thermoplastic. We form that using a proprietary moulding process, and that creates an inner vessel as a first step of the manufacture process. We're able to structurally reinforce that with high strength, lightweight carbon fibre composites. We can use any composites as part of the patented process. And then the intermediate, which binds these two together, is our technology there. And it enables that high-strength union to leverage the properties of both of those materials and create a true new composite material, which is really the combination of two different materials resulting in a set of properties. So that's our patented technology, and it really forms a platform for us to address a whole wide range of markets. In the chemical and gas transport market, which is where we're currently commercialising, we've deployed our technology with good success there. It has applications into a massive market of chemical storage and processing. There are applications into the maritime, into the defence industry, and we're now currently deploying into the aerospace industry. And the interesting part of that, really, if you look at that chain of industries, is industrial applications typically low value, I would say, low price, very competitive, and aerospace, high price, much greater barriers to entry and therefore higher value. And so our technology is really deploying into the extreme ends of these markets, but have opportunities also across those different sectors. It's difficult to do this. Collaboration's a key and really helps you to put together the pieces of the puzzle. Early in our journey, market research, know before you go. We used a process with the University of California, Los Angeles, called the Global Access Program. It allows you to access primary market research directed by you into the United States market. It's run by the Anderson School of Business, and it's exceptional value. That gave us a really clear picture of the market that we are targeting in the United States. University collaboration. For us, the University of New South Wales is an extraordinary partner. We have employed 5 PhD graduates out of the University of New South Wales. We also take new graduate engineers, master's students, and you know, we're a home for this kind of intellectual output from the university. We also collaborate on fundamental materials research, and so I think in a lot of ways what we've developed over time has been a result of that successful collaboration. With the SOMAC CRC and UNSW as a lead partner in that, I look forward to that continuing and deepening. And look, money is always good and key, and state and federal support grants. The reality is that R&D tax concession as an entitlement grant, we do deep R&D and we do extensive R&D. That supports a program where I don't know how countries who don't have that are able to innovate in the same way. The AMGC has been a great partner for us. As I said, the United States road tanker was supported by the AMGC by a small grant. We got $250K there, but it was much more than money. The support in the launch and through the process of development, I would fully recommend AMGC as a resource for manufacturing companies. Oz Industry federal government grants. We have currently an application in for CRCP, which is a Cooperative Research Centre project grant. And the Western Sydney Parkland Authority is going to be a really interesting tool as part of that whole development process. This a little bit more on the collaboration that we're doing to develop liquid hydrogen tanks for space. There's an extraordinary challenge there associated with liquid hydrogen at minus 253 degrees C. And at that temperature, materials really struggle to perform as they do at room temperature. For composites, the mismatch between those, the fibre and the reinforcing, or the reinforcing fibres and the resin matrix means that containment of liquid hydrogen is really challenging. So we've got two avenues of research here resulting in full-scale prototypes for Lockheed Martin for their commercial civil space launches, for a workhorse satellite for them. So it's supported by AMGC. We have fundamental materials research happening at the University of New South Wales, Omni Tanker's technology and capability in manufacturing, and a large end user in Lockheed Martin. So it's a kind of example of complex materials coming together and fully engineered and manufactured into a product which has a large application there. And as a result of this, we also have opportunities in other satellite launches and the space sector more generally. I'd be remiss not to put in a smiling curve as well. I'm a happy guy. It's interesting for us, we reflect on this and, you know, that sort of push towards the high value add. But my true belief is that you can't just be high value add. If you sit on either end of that only, without an overlap into other areas and fundamentally being able to make the thing that you're designing, you miss a lot of the value associated with this industry that we sit in. So this is what we do. We do R&D, design, we manage the logistics of our products and we manufacture them. And we also do the other part, which is after we've produced them, we distribute them, we sell them and we service them. So it is sort of touching all of those sides of it. I guess where our deep expertise sits and where we're able to change the dial is more in the R&D and more in the design. But the absence of being able to produce it would leave us in a very different situation. So I think that manufacturing capability is something that, and obviously pandemic and supply chains create a realization that if we're not able to make stuff but we only design it, we rely totally on the rest of the world. You know, a pandemic's one thing and war is another. Those kind of capabilities are necessary in our country. So I think supporting those not through grants but through access to capital and you know, the support from our own industry is really key. So for us, it's a consideration of the opportunity and the risk and reward. It's a big global market. It's you know, we have a population of 25 million. The mining industry here is strong. There's large distances to move, so it's been a good domestic market for us, but it's a much bigger market offshore. And so the products that we've developed have opportunities in the United States, which we're now addressing, and in Europe, which we're also now addressing, and globally with the tank container. So the path to commercialisation and optimising that is the next stage of this in that smiley curve. How do we really capture the value that's embedded in these international markets? It's a big challenge, you know. It's really, if I was able to find that drawing to scale, the fish pond for Australia would be much, much smaller, and the fish bowl that we're trying to jump in, there is a big gap, right? So you have to understand the market. You have to understand it really well. You have to know what the standards and certifications are, and that Australia has different standards and certification for dangerous goods transport tanks than do Europe and than do the United States. There is, like the Lord of the Rings, one ring to rule them all, and it's called the United Nations Model Regulations. It's actually not a regulation, it's a set of recommendations. It's a big orange book for the transport of dangerous goods. But that United Nations harmonised standard for transport of dangerous goods gets adopted by the world standards, the world regulatory bodies. And we, as a very small company in a small manufacturing nation, sit as part of the United Nations Model Regulations Working Group for FRP portable tanks. So we were able to influence the standards and regulations that will now roll out globally for FRP portable tanks. And it's not like it's a big group. We sit, Luke and I, in a room in Geneva with 25 other people forming the standards that will come to govern our industry. So if you can get there, that's well worth it on the standards and certification side. You've got to know what you're up against, what are the alternatives. It kind of comes back to that deep knowledge of the space and the materials. I was blessed that my father was mechanical engineer in the FRP industry for about 50 years. So we knew what state of the art was. And part of the patent process is to actually understand what is state of the art. Have you something novel? Is there an inventive step? And the tragedy in the patent world was it obvious with what was already known? So I can share some more stories on that. But knowing competition, knowing how you're better, knowing your value proposition is key. Partners on so many different levels. We've done joint ventures with varying degrees of success. Joint ventures are challenging because everybody wants a piece of that same pie that you're generating. IP protection is key, and funding always. You know, that for that goldfish to make there, he needed to eat a lot of fish food. So that key part, which Kelly mentioned, that everybody is facing, is how to grow successfully and how to fund that risk-reward piece. So what's next for us? I don't even know how I'm going for time, but what's next for us is growth to build and support our international sales, to expand our suite of developed products, including integrated baffle structures, which are using our technology, but will really change the inside world of chemical transport. We're establishing US and European distribution, and we're leveraging our technology through this project with Lockheed Martin into the emerging market of hydrogen transport. So high pressure gas and liquefied hydrogen. The Western Sydney Parkland Authority's Filament Winding Centre will be interesting on that. But to be able to compete globally, I think you have to have a technical advantage. And I think that's when I first started this out with my old man in 2006, it was, we have to be different to succeed. And I think that's a key message for Australia, that sort of number 8 fencing wire, and back to what is the technical challenge, having the deep technical knowledge to do it, having the team and the resources there, but the inventive step, and I think that's what we can do very well. Thank you. What's that?
Although I would like you to, if you could share with us, just really quickly, how did you find tapping into all the amazing resources that are available through all the different agencies? Because you demonstrated some really great, strong collaborations with universities, etc. But how did you get into the funding? How did you connect with all those industry partners?
So we started in Maxville with 4 people, and an Aussie industry representative from Newcastle came up there, and he said to us, we didn't know anything about grants or R&D tax or anything like that, and he said, you're a very commitable company. This is in 2006, and there was an Aussie industry program called COMET, which was commercialising emerging technologies. It was a very low doc grant process. I think we got $54,000. It was a game changer for us, and it was a game changer because it put us in contact with people who allowed us to develop a business model, financial modelling, a business plan, and then gave us access into capital. So this project and our company was genuinely funded by me and by friends, fools and families for the first couple of years, as I think many early stage startups are. But to get over that hump and actually get into a bigger market, our first major contract was with Toll Mining, and it was a $4 million contract. So to go from producing 2 or 3 tanks first to get a $4 million contract is a kind of big step, and that access to capital to build the machinery that's required is it's a challenge. So yeah. Oz Industry was a great help, continues to be a useful resource. Yeah.
Terrific, thank you.
I'm happy to take any questions if anyone has.
We've got 5 minutes if you'd like. Anybody have any questions? If not, you're off the hook, Daniel.
Cool. Awesome. Thank you very much.
Thanks so much.